And so what we wanted to talk about today was how this seal might be applicable in applications to your plants, such as low-speed applications, which will be the first half of the seminar. And low speed is usually defined as 300 RPM or less, like agitators and pumps going through gearboxes and that type of equipment. And it's twin screw feeders for dry powders. And then we also have high-speed applications, which are synchronous motor speeds, like centrifugal pumps. And they're two little bit different animals as far as how Tamar approaches sealing those applications. So that's why we're going to divide the two little, parts, maybe a short break in between. So I'm going to introduce Mr. Udi Horowitz and let him get started, and then we'll have questions and answers, and we'll have a handout here at the end. And anything we can do to help you with your applications, we'd just love to do it. So Udi, why don't you go ahead and take the floor.
And he started this idea of Tamar Technologies when one of his customers was in the Dead Sea. And his problem to seal boats in Dead Sea. Dead Sea is quite a unique place. The water is very heavy, you can float there like space. And but the water are heavy and salty. So mechanical seal is not an option there. And use packing, but it was a lot of problem to fasten the packing and work with them. So Ronnie thought about ways how to help him. He found in the internet something called injectable sealant. But when he suggested to his friend said, okay, I will put some injectable sealant, but in 1 day or two, the pressure will go and the boat will sink. And then he came with the idea of a booster. I mean, this is practically a booster. When you put pressure here, it multiplies the pressure in here. And whatever you need, the pressure is there. And if you have some kind of reservoir of sealant, he will compress it to the stuffing box, and you will have a constant pressure. These guys thought about it, asked his boss, and said, okay, we will pay you if it works. And guess what? We are here 10 years after, and it works. So, Tamar Technologies started with that, and it goes from that idea. Year after, I met Ronnie, like many other people in Israel, we meet in the army. I was his commander in one of the units in the reserve. Every year we meet for 1 month to train and so forth. So I met him, I know him almost 15, 20 years. And he came with the idea, he told me about what happened there, and I said, well, it's a very great idea, and I joined the company. And we started there Tamar Technologies. Tamar Technologies starts with the problems we face next to the Dead Sea, ICL. A lot of powder, aggressive powder. The heavy industry in Israel is in the south, and Ronnie and Tamar Technologies are in south of Israel. And we started to order in a big and huge application. I will show you several of them. Then we came out with the high speed. We're going with pump as well. Jack came to us and joined the family of Tamar. So this is Tamar. Right now we're distributors in the US, also in Chicago, here in the US, and also in Denmark, in Europe, Germany, Netherlands. And we are hoping that we will have many more in the coming future. So, I will start first of all in a place where we are, as Jack told us, in a low-speed application. Different between we see in the low-speed and the high-speed application, where high-speed is most of the way it's standard. There is standard, you buy it from the shelf, like any other standard seal. While low-speed application, most of the time, they are almost tailor-made. You need to understand the application, you need to understand what the full process is, and to design your solution accordingly. In Israel, because we see we have so much success in that kind of application, we have contract with OEMs like screw feeder manufacturers or rotary valves that say, okay, they propose to the customer, you want this screw feeder with Tamar technologies. It goes together right now, so we're becoming standard, and I hope in the future we'll be standard here as well. So, do not mix with us. Okay, so let's run it. Okay, this is screw feeder as you see. This is our seal, and this is for cutaway. This is demonstration. Please stop running. Okay. Yes, stop. It's me. Stop. Okay. So. And in that way, you can see what is going on. We have in the seal what the sealant that I'm talking about. What is the sealant all about? Sealant is a material. Give an example of a sealant. We have it there. Okay. Sealant is like graded packing or lubricate, but this is about it. Okay. We sometimes add some ingredients to it that it will be more stiffer and it can hold the pressure or so forth. But this is the sealant. This is the seal. In both sides of the sealant, you have packing rings that hold the sealant that it will stay in here. And we have a sleeve. The sleeve has a special geometry that create in that point vertical faces, and this area become like mechanical face. With sleeve and sealant, and they are in parallel faces. One is stationary, one is rotary. So this is like mechanical seal. So you have sealant, you have packing rings like packing, and in here you have labyrinth, and in here, you see here, this is the air coming, and in that area it creates a high pressure, and the air goes to against the process. Here you have packing ring as well, in order to maintain lowest tolerance as possible, that you don't need to waste much air. Okay? We put a high pressure in very small place in order that the process will not go in. But we don't want to waste just water. We don't want that you buy more application, more machine that create air. Okay? Compressor, of course, process will say your compressor whatever you want, but we want to stay. Okay? So
let me mention one thing. So the flexible sealant fills every nook and cranny in that angular space that's around the OD of the shaft sleeve and the ID of the stuffing box. It does not move. It's static. It's stationary. So it's like a stationary seat in a regular mechanical seal. The crenellations, or the ridges that are machined up and down the length of the axis of the shaft sleeve, the vertical part of those ridges are like a rotating head on a mechanical seal. So you've got a flexible stationary seat and a rotating head, and you've also pressurized that flexible stationary seat.
So in one seal you have packing, you have injectable sealant, you have like mechanical seal, and you have air pressure, all in one seal. Okay. It's give you just some kind of insight to understand why it's so strong, why it's holds such environment that we're talking about, this kind of seal. Okay. So this is the theory, and of course you would like to see some kind of demonstration of it. And I will start with something that we installed here in the US.
Yes, you've all heard about the shale oil drilling up in North Dakota. This was up in Williston, North Dakota. This Beetle was actually a company in Pennsylvania that made a machine for reconstituting drilling mud. And one of our visitors here, Rob Porbeck, his brother Frank Porbeck owns Porbeck Engineering in Little Rock, and they designed this pretty much this entire plant and the way this seal fits in this machine. But you can see here you've got two shafts, two screw feeders, and drilling mud is reconstituted when you dump the used drilling mud into a big grate and down into a hopper, and it feeds this big hopper and container right here with the screws. The screws mix it up, and then they take it to a heater, a very special heater made by a company called Thermoflight out in California, and it bakes the old drilling mud and gets rid of the diesel fuel and everything else that's a contaminant. And they actually reuse the drilling mud. They re-inject it again. So it's just a continuous process over and over again. This top right-hand photograph shows these were 5 and 15/16 diameter shafts. We put 2 Tamar seals, split seals on each side. Those seals weigh 120 pounds apiece. And you see we're using 2 boosters. The reason is one booster will typically handle up to maybe 3-inch diameter shaft, give or take.
In order to stay with a constant pressure all the time, it's such large diameter, you need 2 boosters in that kind of case.
Sure.
Again, this is split seal. We able to provide you a split seal which easy to install, easy to maintain, easy to take out and pull back. And how much time it takes for you to put these seals?
We had three hoppers. Each one had two seals at each end, so it was a total of 12 seals. And I'd say to install everything, and you can see up there the weld marks on the top right-hand photograph where they had to weld the end of what is really the metal stuffing boxes to the side of the hopper. It probably took 2.5 days to install all that and put all that together. Those shafts turn at about 1 RPM. They're very slow turning.
Let's see them, okay? So when did you install it?
That was about 1.5 years ago.
And just see, this is low velocity.
Very slow turning.
Very slow turn.
So the Bluetooths are what, Dad?
The what?
The Bluetooth?
Those are just air lines going to the various boosters and the air flush on the ceiling. And this was just set up, this is not the way that it ended up being, that's just the way that it's set up from the test.
This is the nut. Okay, look at it. This is the bubbles from the air flush. Okay.
So this is the grate that the truck actually backs over that has the used drilling mud and then dumps it into this hopper. That's actually top of the hopper. You're seeing they're full with liquid under the grate.
We are talking about mud, sand, abrasive, with oil inside, and so huge. The tolerance there is not so tight. So just think about what kind of application, what kind of sealing can work with that kind of application. Packing. So Tamar seal worked 1.5 years and more, and it will be quiet for the next 5-10 years to come. Let's go continue. Another nasty application is sugar. It's sticky, crystallized, very hard to work with, very hard to seal, and when you use packing, and then packing always leaks in sugar. It's sugar, it's sweet, so flies come and build, and it's becoming huge problem, environmental problem, and people cannot work. It's very hard. So there is quite a big factory in Israel called Sugat, and this is what you see. They installed our seals. This is the 4-inch, but right now we are continuing installing more and more seals in that factory. Last month it started right now, 8 seals, 6-inch shaft, and we are continuing. They understood that we have a solution for them, finally, after all these years. Okay. These are demonstrations about the abilities of that kind of technology to help you all in figure out and work with materials, application that right now we have problem with them. Another tricky application is that one, which is 7-inch shaft diameter, 20 RPM. Problem in here was this is an agitator. The problem that is rotate and also go up and down. Reciprocate. Well, let's move forward. This is a split seal. We installed that a few years ago. You see the shaft here, the colors. It's so hot there that they change the color of the metal. Okay? It's rotating and moving. This is is our seal.
Point to the booster recruiting in the seal.
Okay, first you see the booster, you see the seal here. Okay. This is the MTZ, this is the seal.
You have a booster on the backside on that one as well. Sorry.
When you will be there, if you will be there, it's called comfort, you will see many agitators. And they called it Tamar, Tamartic Road. Tamartic Road, because street, because everyone, you will see the Tamar seals all over. Yeah. Always, you know, we start with the most difficult application, say, okay, saving that done, we'll talk with you later on, we see it's working, continue with that. Okay, so let's move to another agitator in the same place, very hot one, 128 Fahrenheit. So what we did here, we put a pre-cooling jacket here below, and the unit itself is also cool. So we're able to run very nicely the cooling environment, seal very nicely this application without any problem. Again, I would like to, in that point, to just describe you the engineering behind Tamar. When Ronnie had this idea, he went to his brother-in-law called Dr. Santo, which is he's one of the professors in Ben Gurion University, and this guy is expert in finite element methodology. And he thought about Ronnie's idea. He put it on a computer, testing and all of it. Said, okay, it will work. Okay, great. And he advised her what to do the next one. We're talking about the next one. He has a son, Nir Santo. Nir Santo is going to be a doctor in mechanical engineering as well. And then Nir Santo is the head of engineering in Tamar Technologies. So, I mentioned all of this because you see here, there is the innovative, and Ronnie have innovation every day, almost every day. We come in with a new thing, but everything goes through a process of engineering, testing, and to provide you in the end a solution that was tested in the computer and in the real life as well. What you see here is the seal with the bearing. All of them is in one unit. Okay, the run out here of the agitator was wide, so we put this bearing and it's going to fix this situation. This is very strange application, but you will meet such. It's called a bucket elevator. You know that? What is your name, please?
Trisha.
Trisha. Nice to meet you. For where are you?
I work at Lucite. I've actually seen them at two other places I've worked had bucket elevators.
Yeah.
Whole industry.
So bucket elevator, what can it be in bucket elevator? What? But here, bucket elevator, this one is horizontal one. The powder is so fine, it's like water, just split all over it. So we tried, of course, many things, and here you see the solution, Tamar Technologies. Okay, just run this video. Because it's so fine, it's like water, we put in the back, you see here, automatic greaser that close all the tolerance that you have in the packing and the injectable sealant. So the grease close all this tolerance because the pressure is very low. It's just a bucket elevator, and in the end you have a perfect solution.
So note that booster does not use air. It's completely self-contained. That's a different design booster that Tamar has for certain applications.
Yes, it's again what it does is when you have areas where you need to close it in a small place. So we put in this tolerance because it's something moving, and the packing of course cannot trace the fast moving of elements like packing. This is why you have always leaking packing, because the shaft is vibrating and the packing cannot, of course, run with it. The injectable sealant is closer than that because you have the constant pressure and you have also the seals, but in places where you have material like water, we add the extra, which is what you said, the automatic breather that close all the gaps, so you have perfect solution. Okay.
How long does the sealant fluid last? Do you end up having to replace it?
כמה זמן הסיל הזה, אלמנטר, טקט אלמנטר, כמה זמן הוא עד שם או הולך לעבוד?
כמה זמן אתה אומר, זה הרגע הקטנה?
חצי שנה. So it's running, like I said, it's running for the last 6 months with no any problem. We think it will run at least 3 years.
They ordered more tools now.
They ordered 2 seals more, and by the way, in many of these applications, we are providing at least 1 and 1.5 warranty anyway.
Right.
So, no problem there. Okay, this application is a very long one, and this shaft is very long, and it's different with the temperature, creates different with the shaft. No, shaft.
GPS signal lost.
Someone is lost here.
Recalculating.
Okay, so there is a change in the shaft itself. So it's moved ahead and back in around 1 inch. When it's hot, it's there. When it's cold, it's here. And we need to cope with it. So we add bellow. So you have the bellow that take these differences, and you have our seal, hold them so. Okay? This is in US. Next to Chicago, you will find that solution. Okay? This is in the installation of the seal. Again, most of the seals are splitted. Again, easy to install, easy to maintain, easy to work with. So for you, it's a really great benefit. Okay? You see this is the booster here, connecting, and this is the bellow here. In each this seal, we provide also a control panel that you can control the pressure of the booster and the pressure of the air flush if you need to add air flush to the system, so you can control it in order. The air flush should be the same pressure that you have in the process, a little bit more, but not more than that, in order that the fluence of the air will be as minimum as possible. It will not influence your process. It will do everything good for both sides, the seal and the process. Okay. So again, ICL, pag mill. Do you have pag mill in your area? Let's run it. Okay, this is a test. This is very old, I think 7, 8, 9 years movie. And you will see here, stop, can you stop it? Okay, run it again. So they wanted to do a test. They put Meko seal and Tamar seal one next to another, and said, okay, let's run and see who's better. What's more than that? So after 3 months, we came to see. And you see this is dusty because it's not new, okay? But here is clean. Look at it. Okay. Meko seal is very nice product, but it's very limited. You put a lot of air, but when it's out, it's out. That's it. And this is the main problem with that kind of solution. While this is dynamic solution. You see there is a booster, there is a reservoir here, and in always there is, make a pag mill. It's very big one, robust, and the tolerance there is disaster. So you need always to be like babysitter, you know. So this kind of solution, this is what it does. It says, okay, I understand that you cannot be next to the machine all the time. I will be here with you. The booster put the sealant, that's it. Once in a half a year, they add a little more sealant, that's it. 5 minutes. And they can add the sealant while the machine is working. You don't need to stop. Just add a little bit sealant, continue. Okay. Of course, right now, all the apartments are with Tamar technology. This is quite new. ICL flaker. What's strange in that is that the stuffing box is rotating and the shaft is stationary. Well, this is different approach, but here, see this is the cutout of the seal. And let's see it's running. This is ICL here, and you see rotating here, and this is the booster right there. Okay. Continue. So you see that there are many applications, many kinds of applications. You need strong engineering team that look at the problem, see what we can do, and design for you a solution. Okay. Again, inside it will be the same. We're always talking about how to take this good technology to your application. Inside will be the same. It's very easy to maintain, very easy to work with. All the problem is to put it in your system. Okay. This is a bottom entry, very hard to seal. Bottom entry mixer, and we put bearing here and put our seal here. You see, this is the entrance to the booster. This is the sealant goes. This is the packing. We have it. This is the air here. Okay. Nitrogen. Okay. Thank you. This is nitrogen. Okay. And this is as you see, rotary valve, very old one. So the very old rotary valve, and they put the packing not in front of or not on the shaft itself, as you see here. They put it very distant. So they replace packing every month, something like that. So until they had enough and said, okay, we understand we need to fix that. We change a little bit their design, we put something, but in the end we put our seal, and that's it. It's, they have a system that's running without any kind of problem, and they're very happy. Magnetic separator. Magnetic separator, sometimes you see the design of elements, and you think to yourself, hey, my friend, you didn't think that it will ever go to leak? This is what do you think of? Well, these guys took the magnetic separator and put the gear on the shaft on it, and said that the gear will be the seal. Gear seal. This is what they started, and this is magnetic separator. It means that it should collect the metal parts in the process, and metal parts now quite abrasive, you know. So in the end, every few months they replace a gear. Stop the system, blah blah blah. Well, they asked for our help, and we designed. You see all this. Take the gear out, put everything inside, and we engineered all this environment in order to provide the solution. You see here the seals, they installed it, they were happy. Okay. Another one that we took another step in engineering, not just the seal itself. We engineered all the system that holds the seal. Is this top area? We took, again, they have problems. See that this one. Only this is the packing, the problem, the heavier the that water went inside and contaminated the process. There was a problem with that. So we took all this motor and gear out, put the change here, and put our seal here. And they did all these changes, and it worked great. Another engineering issue and another thing is chopper. And I don't know if you know such application, but the first design was that the seal will be the bearing. Well, it's cheaper than gear. But yeah, every month or two they should replace a bearing. It's been a crane. You need a contractor. It's good for give money to all the guys there, which is very nice. But in the end, the accountant says, oh, maybe we need to do something. So they came to us, and of course we designed it a little bit differently, and put our seals here, and now the accountant is happy. Maybe he will have a more bonus, I don't know, but he's happy. Okay, this is about, you see the application we're talking about low speed, most of SUC, low speed application, but robust, using abrasive material. A big one. It's a lot of work and a lot of understanding what's going on there. And the solution here provide you 100% success. And all the application we did, that's such kind of application went good, and we are very happy for that.
Some of the mixture seals that I recall that Tamar designed and built successfully included a bearing in the actual seal cavity, correct?
As I told you, as you saw here, in some cases when there is a mixer or a potato, when the runout is too big, our seal holds inside a bearing. Okay. Any question on that part, friends?
Would y'all like a 5-minute break, or would y'all want to continue on? I know some of y'all got a good ways to drive, so however y'all want to do it.
Keep going.
Everybody still comfortable?
Download the applications. Of course, there are different pumps, different sizes, different pressures, but in order to work with pumps, you need to be standard. Okay. So how many of you are pumps guys? So many. Okay. Yes, sir, you are pump. I know. So let's start with high speed. Okay. As you can see here, this is standard seal. It's replaced cartridge. Okay. You take out regular seal, you put our seal, and it's plug and play. It's the beauty of that. We took all the things that we talked about, and we just compress it to a small space here. You need to be very accurate, and very know how in order to do such thing. So it took some time, but we succeed. This guy, as I told you, he's a genius in that. So you will see cutaway of this this pump. And Ronnie, if you can just a little bit, when you closer, no, run it, and I want to see it a little bit closer. This is the air running. Close. Stop here. Stop here. So, what you saw in the big seal, the LLC, you can see here as well. So, you see here the compressed ring, you see the sealant, and you see here, this is the air coming from here, and create here, high pressure. It's a small place. When you put air in that so small place, it becomes high pressure. And if you have a 5 bar in your lines, so you will have 5 bars, so it means that you can hold 5 bar against the process, and I mean the stuffing box pressure. Okay, it's not the stuffing box pressure. So, and this air goes from here to the outlet of the pump. I know that you read in your book that you don't need to put air in pumps. Something, don't put air in pumps, and we found that this is the case here. But we tested, and we saw this is a big difference between regular air that goes from the inlet of the pump and this pump, because if you go from the stuffing box, it doesn't interact with the expeller, it just go out with the stream and that's it. It doesn't affect the pump at all. Okay. So you have here positive pressure against the process that wants to come in, does not interfere with the expeller. You see it go from the back of the expeller out, and that's it. Okay. This is the basic concept. Basic concept of the seal means that we have what we talked about before with the seal and the packing, and we have positive pressure in front of us. This is an active. We are not trying to build a material that can hold that will be harder than the process, that can hold the abrasive material like mechanical seal. So I will add another phase and another phase and another phase. No, I'm a different story. I'm saying to the process, hey, stay where you are. I have a air defense, and then I will be in my side. One strange thing, if you think about it, we talk about mechanical seals, that one day I came home from work, and I saw my wife look at the wall. I say, why do you look at the wall? It says, light green. I said, what light green? I think it will be painted in light green, all the room will be different. I said, okay, if you want light green, we will paint it in light green. He said, no, maybe light blue. I said, light green or light blue? I don't care, I don't know colors, but I don't know. But you know what? Our neighbors are redecorating. I asked their architect to come here and help me to decide if it's light blue or light green. 3 weeks after, we destroy half of the house and we redecorate. So, light blue. You can laugh a little bit. It's story. But when we decorated, I wanted a door, because we destroyed a little bit the house. We need a new door. So I bought a friend of mine bring me a door, and it was a really strange door. When I opened it from outside and there was no one in the room, it's not working so well. It was noises, but when I was in the room and I opened it, it was great, it was smoothly, no, nothing. And I said to my friend, hey, what did you bring me? He told me, look, when you are in the room, you need door. When you're out of the room, you don't need door. Well, why do you care? Well, my friends, what do you say about it? You are in America, you are a lot of knowledge. Are you going to buy such door? I think you will not buy this door, but we all buy mechanical seal. And when you buy the mechanical seal, it's the same. So if the process in the pump, it works well. But if we will try to work with it, and there is no process in the pump, it will burn out. And we buying this door, all of us. And when you think about it, it's quite a bizarre. The door that is not open when people inside. Okay, so Tamar seal is different. And I want, can you raise the volume? Volume?
Try on the TV.
Okay, no problem. Jack, this is yours.
Well, this is a Griswold ANSI pump that we had at my test pit of my old building, just pumping water in a closed loop. And when Udi left out part of the story, but I showed this seal to an engineer at DuPont in New Johnsonville, Tennessee. Scott White is his name. He's a really brilliant guy. And he said, you know, we're pumping a really abrasive titanium dioxide slurry. And he said, if there's some way that you could bleed air through the seal and have it come out the back and help push the particles away from the back of the seal, that'd give the seal longer life. I thought that was a good idea, so I gave it to Udi and Ronnie. They did it in a lab over in Israel, and it changed the course of their company because instead of well, what Scott thought would happen, you drill 4 holes there in the back of the seal, you get like a helical stream of bubbles that would push this abrasive slurry away from the back. What happened is one big bubble forms, and it just sits there between the back of the impeller and the end of the stuffing box, and it's a perfect tortuous path. Nothing can get past it, and so that's what.
Right. Okay.
So what I did was I had a plexiglass stuffing box cover made for this ANSI pump, which is right here. If you can see it, I wanted to see the bubble. I wanted to see the phase separation. So here it is right here. This is the beginning of the bubble, which extends back here. This is your impeller over here. This is the booster. And so we're pumping water, and we're not leaking. There's the bottom of the bearing housing right here. We're not leaking, so it works. This is the real deal. So I proved it to myself that this thing is not just some smoke and mirrors deal or some idea that doesn't make sense or doesn't work. It really works.
So the air is distributed evenly around the...
It's like a ring. It's like a ring of air all the way around.
Yeah.
And that's what you're seeing here on the left, the injection tube, that where it's turning.
Yeah. We use there for different applications, but in that when we asked them about the pump, we first like there is written in the book that air inside, but when we test it inside, we see what it does. We change the design of the seal, we see the result right now.
And it'd be saying this in about 3 sentences. This was about a 6-month project to put air into the seal and see if it vapor locked the pump. We did it with the Gould's 3196 1.5 by 310 that's got balance holes in the impeller. And everybody said, well, the air is going to bleed through the balance holes on the backside, come over, put a bubble on the nose of the impeller, it's going to vapor lock the pump. It didn't happen. It just doesn't happen.
Yeah.
And
So the air doesn't even really get consumed either?
Well, the air gets consumed, about 60% of it goes out the front of the stuffing box, about 40% of it goes into the process, and the amount of air on a 3196 MGX 1 3/4 inch shaft is like 0.18 CFM. I mean, it's just not much. And only 40% of that 0.18 is going into your process.
So, this is an example. So this is this is the theory, but I would like to show you application after application of several applications for what we did, what we checked with our seal. When we come to this is in North Chicago. We came there and we saw something like that. This is corn ethanol industry. Right now it's very hard situation where the oil is so low, but still, and the corn here is sticky, torn the seals faces and everything is like a swarm. So this is what we saw when we started there, and let's see what happened after that. And it's very hard application. This is what we thought. Right? You see? Okay. Doesn't matter what kind of mechanical seal you put here. In the end, the corn will either close it, burn it, and then go to talk with the corn. Okay? It's a popcorn. So, running. This is after 1.5. See, it's very old, but still clean. Still clean. And this is the beauty of that. When you put the air against you and the process is not coming, almost not coming, it's a different story. It's a different approach. This is dynamic. This is the acting. Okay, let's continue. Okay. Zach, I think this is a movie. Let's go to the movie here. Okay.
Jack Tyler Engineering of Tennessee and Tamar out of Israel. Install on a Tamar 540 air flush seal on a 3600 RPM Durco at ConAgra Foods in Memphis, Tennessee. About 25 minutes into startup, no leaks, no packing, protruding, stuffing box temperature about 150 degrees Fahrenheit. Temperature of the seal about 115 degrees Fahrenheit. Again, no leaks, screw jack still in currently. Discharge pressure about 90 psi. Regulator on the bubble set to about 15 psi.
Okay. Thank you. Vacuum section. This is another example, but just I want to show you how pumps look like when you go to them. Okay. This is the situation where mechanical seal doesn't work, vacuum doesn't work, and Tamar is to okay, let's continue. Molten salt. Salt. We came from salt. We know what it's salt all about. It's crystallized and it's holds everything and kill everything. But we have a solution for that. We put our seal here. It's running almost 2 years.
It's crazy.
And it's very abrasive. So it's running. Jack.
This is Samad Wire up in Dixon, Tennessee, about 35 miles this side of Nashville. The pump up there, I think these are two Tamar Seal, two different pumps up there on Tamar Seals. They were using a mechanical seal on Italian closed couple pumps on some OEM equipment to pump saltwater brine for cooling where they draw wire and make wire for different companies. And the mechanical seals were failing, the salt in the brine was crystallizing, as you can see in that top photograph. It was getting into the motor on the closed couple side and burning up the motor. It was a giant, giant mess. So they put the Tamar seals in, and that's been 4 or 5 years ago. Running great.
This is a PC pump in a place in Israel, and what you see here is a motor pump, quite a big one. The application, there are several applications. There are sugar and cornstarch. Sticky, sticky, sticky. You see here, you have the air flush, you have the sealant, you have the press backing. The air flush is doing most of the work here. And again, we put here the automatic greaser in order to close all the small tolerance because this mono is vibrating. So we need to close this tolerance with this automatic greaser. Again, these are real applications. This is not just it's here in action. If you have such application, you have a solution. You have a solution for that. And this factory replaced right now 6 of his motor pump with Tamar seals. Okay. Let's continue.
Why the
You see here, we control the pressure of the stuffing box with that the gauge. Here you have ability to change it, and this is one of the big difference between when you take a passive solution like a mechanical seal and active solution like a Tamar seal. You have in your hand, if the pressure, you see that the pressure of the system is high, you a little bit increase the pressure, put a steady state, and that's it. You have the ability to look at the starting box and change what happened inside. And this is a huge difference between what you use until now, put it and hope for the best, in the place that you have a control. You have a control what happened inside the pump. This is the big change.
Why did you have cooling on the last one?
Why?
It said you had cooling. Were you trying to cool the?
We in every seal in our high speed, we have the ability to cool it down. We have a special cooling system. You see here, you have water in, water out. Okay? Yes. Look at it, touch it. Okay. You have free in, out. Okay? The water is going around, cool this area, go out. Just pass it on with the guys that look at it. And what is funny about it that after one day of work, because it's running so smooth with the air, you don't need the cooling at all. You can close the water after 24 hours most of the time. You can close the water, it will run freely, no problem. Okay. The air itself, you just can cool it and providing smooth environment. Okay? But the startup needs cooling. Okay? We have in some cases, we have some kind of small portable cooler. We have a small portable cooler. Sometimes we put it, and after several days, we take it out. By the way, from where are you? Yes.
Here.
From here? I think it was. Okay, great. Okay. Denmark. Yes, I told you we are also in Europe, Denmark, Germany, Belgium, France. Nitric acid, not easy stuff. And what is interesting is the suction pressure, which is like small vacuum. When the suction is small vacuum, it's very hard to seal. Mechanical seal, the faces are open, and the story and the carnival starts. So our seal can, of course, work with that. This is an active, you don't need the process. It doesn't care if the process is in a vacuum. It doesn't care if the process has launched. It doesn't care if the process exists or not. It's like a door. A door is a door is a door. And a seal is a seal is a seal. It doesn't care if the process exists or not. Okay? Pulp and paper industry. Wow, this is a big story. Whenever you touch pulp and paper, you see problems. Anyone here in that industry just knows about it? No. Okay. It's sticky, it's abrasive, it's clog, it's a problem. It's a problem. And we have a very good experience with pulp and paper. Good seals there, and it works great in the same manner that I told you before. It doesn't care if it's sticky, great, it helps us. Because sticky is good. It helps us. It's before the air, it stuck, it stays there, the air is against the sticky stuff, and it helps us against the other sticky stuff that wants to go in. You use one guy against each other, so it's okay. Let's move 3 more, and I want to show some guy which is knows very good about pulp and paper, and can go for further more. קדימה אחד. This is in scan pump in Israel. Again, we installed there a lot, and this one here. But I want to show you. I want you this one. Yeah, this one. Knows a lot about pulp and paper jack.
This is a pump up in Packaging Corporation in Tomahawk, Wisconsin. It's a Goulds 3196 MTX on black liquor at about 180 degrees Fahrenheit. Black liquor is a very insidious liquid. When it's at temperature, it's very, very thin and will find any crack it can to leak out. It just does. When it sets up at room temperature, you can peel it off the floor and throw it across the room like a frisbee. It's just really weird stuff. So it leaks. It's very difficult to seal because it sets up so hard. When they stop the batch process and pumping, the seal faces just coagulate and just stick together. And then when they go to start it back up an hour later, it just shears the seal faces and leaks. That's the nature of the beast. So what they do in pulp and paper is they flush the seal faces with water. If you do that, the seal will last a year or more. But the problem is it costs about $24,000, and we've done the studies with 2 different paper mills per pump to take that black liquor to the evaporators and boil off the water before you go on to the recovery boilers and use it for fuel. So it's very expensive to flush those seal faces with water. So what we're seeing here is a pump that's run now almost 4 years, and in between batches they hit it with steam on the suction side of the pump. When the pump pulls a partial vacuum on the suction side, that steam and hot condensate flashes, and that pump jumps all over that base. So a Chesterton seal was living about 6 weeks in that environment, and we've been in there now for 4 years, and it just, with the air flush seal, it just seals. This is the 1.5. See, yeah, that's the 1.5 by 310 with the balance hose. That they were concerned that the air was going to vapor lock the pump, and it just didn't happen. That's a tough application right there.
We have the one in New York.
Yeah, that's Finch paper right there.
Finch paper.
That's red liquor at 220 degrees Fahrenheit. They've got 3 or 4 of our seals up there in New York. There's only 2 pulp and paper mills in the U.S. that run red liquor, and they're one of them. And they came to a seminar that we had here about 3 years ago at the Taffy Show, and ended up buying a couple of seals, and they worked out real well.
So this is the difference between a passive solution and active one.
I'll tell you a cute story. We were up there, Ronnie and Julie and I were up there, like I said, about 3 years ago, starting these up on red liquor. And the engineer was still a little bit skeptical, but he was willing to try it. And so Ronnie says, well, the pump's running, they're pumping a batch, right? I mean, they're in process. Ronnie said, let me show you how easy it is to change out this booster and this sealant. So while he walks over to the pump while it's running and turns the air off and unscrews it and starts backing out the reservoir tube. This guy's eyes just got this big. No, don't mess with it. No, it'll be fine. It'll be fine. So he does it and changes the tube out. I'm sitting there timing him. He does it in 3 minutes. It may not be the safest way to change out something, but the point is that if you do it on the run, if you can do it on the run, you can. That same engineer called me about 2 years later. They had lost all power in the mill. It was dark. He was calling me on his cell phone, and he says, my pumps are starting to leak. What can I do? And I said, get you an air can at Walmart or Sam's, go down to the filling station and fill it up with air, hook it up to the back of the booster, and he did, and that got him back up and running until the power came back up. He'd lost all of his compressed air.
Okay. Again, this is another story about scan pumps, which is very popular in Israel for pulp and paper. We have the same problem Tech said right now, and we change it to our seal. Okay, so again, this is change of thinking. Right now, the world is using mechanical, which is very good for standard stuff. But if you have something that is different, needs different approach, we are there. Okay, let's go. Let's continue. Finch paper, just explain about the Finch paper, and this is
That's Mid-American Distillations in Hot Springs, Arkansas. They blend a lot of different kinds of fuels. I'm not really sure what this is running. I think that's looks like it's a Goulds 3196. They've got the Goulds and dirt over there at that plant. But it's a Tamar seal. What you see under the stuffing box in that pan, that's where they were catching the runoff from the previous seal. That's, yeah. But look at the channel going through the pan. It's dry. The Tamar seal is not leaking.
yeah. And again, this is the control that we talked about. You have one on the booster, which is very easy to see, and one is go flash and create a bubble. Okay. Line slurry. We have several applications like that. And line slurry is a really difficult application if you ever work with that. It's like sand, very abrasive. So we have such an application in Sugat and also in the south. Again, the temperature is not an issue. The issue is the line slurry itself. And whatever they put there doesn't work. Line slurry is sticky, it's abrasive, and it rupture everything that they put. Most of the time, they replace seal every 3 or 4 weeks. And they afford to even go to packing. But in the end, we put our seal and it works great. You have a story, the line story yourself.
Yeah, we have some folks here from J. Huber, and they've got a Griswold online story, I guess, that we started to seal up on, what, a month ago, something like that. It's doing it.
Okay. So, like I said, just pass it on.
It's just a booster with a disconnect from the air, and you can see you've got a rod here that tells you where the piston is in its travel. So if the rod comes down, you know that you're getting a little bit of sealant, you fill it back up. You've got a reservoir tube that sits right down here, which is right here. So this screws here, this goes in, this has extra sealant in the tube right here, and then this is your air back here, or nitrogen. So you just got a simple O-ring piston right here, just moves back and forth. And this rod tells you the position of the piston. So at a glance, you can go by and look at that tube and see where that rod is in its travel and know where the reservoir is as far as sealing.
How long does the seal last?
How long does it last? We've had some last 3 or 4 years. We've had others that have changed out 6 months. I'd say 6 months is about the most frequent, but that's very unusual.
Like an accidental high air pressure damage it?
It won't damage it. What happens is it starts pushing the sealant out through extruding it through the seal. That's when you know you've got too much air pressure. And that reminds me, I'm glad you mentioned that. Because right here, this is the procedure that I've got. And I'll pass this around. Sure. This tells you exactly how to set this seal up as far as the air pressure, and also gives you a little sketch on the back. You got to have 2 separate air lines, one to the booster and one to the bubble on the centrifugal pump. And this gives you step-by-step how to do it, how to set it up. It's just hard to mess it up if you just follow those steps. And at the very bottom, it's got a YouTube link where they talk about that and guide goes through.
Hey, Jack, is the quality of the air having an impact on how
It can, yeah. We had an issue with that in Evergreen Packaging in Pine Bluff, Arkansas. They got 90 pounds at the compressor and about 57 out where we had the seal.
Yeah.
And the air was really poor quality, had a lot of crud and scale and water in it. We were able to make it work, but it was close. That booster, if you think about it, if you look at the booster that's going around, say it's 3 or 4 inches on the air side, it's only 1 inch where the rod comes through. So you're multiplying, your diameter difference is about 4 to 1. So you're multiplying, that air signal by that amount. So if you come into it with 60 psi of air, you got a 4 to 1 multiple, you're putting 240 pounds of pressure against that seal, which is more than that. On the booster, on the seal? Well, that's a great question. Tricia asked what the metallurgy does seal come in. Standard is 304. We made about a 316. We made about a 316L. We had a customer out in Utah that was pumping water with phosphoric acid, and he needed alloy 20. And so the price of the seal was astronomical. And so what we ended up doing was the customer shipped, because everything in Israel is 3 times what it is over here. The customer shipped Tamar a block of alloy 20 metal. They cut the seal, and the price was like $700 for the seal, because all they did was do the machine. So it made a huge difference. Is coating an option? Oh, is there coating? I mean, whatever metal that you need is not a problem, it's just the expense of the metal. And it's so expensive.
I think it's cheaper here to buy the metal.
Oh, yeah. Absolutely. Yeah, if you have something that needs an exotic metal, it's definitely cheaper to buy a chunk of the metal here and ship it to Israel, let them cut it on this Haas 4-axis CNC machine. And on my second trip, I've been to Israel 3 times. On my second trip to Israel, we actually did a drawing at the Tamar offices, then drove 2 hours to the Gaza Strip. The second time in my life I've seen guards with machine guns. That's kind of a weird experience. But that's where the machine shop was, and they have true CAD/CAM manufacturing.
It was
It's
not
really
in
good.
Gaza Strip, my friend. What?
He hadn't told you he's a lieutenant colonel in the Israeli tank corps. He's a combat veteran, so yeah, that's the story for another time. But in any case, they have true CAD/CAM manufacturing where they import a drawing and they plug it right into the CNC machine and it starts cranking. I mean, so if your drawing's right, the part's right. It's pretty impressive.
So so the other seal similar to such, it has a seal, the double auto seal, right? What's the advantage? I mean, I know there's some advantages, but why? You know what I mean? The double mechanical seal, the flush.
Well, I guess a couple of things. One is you got the price and the expense of the seal pot. Somebody's got to monitor it to make sure it stays full of water. Then if your water is just compatible with what you're pumping, but you don't really want it in the process, you got to take it somewhere else and get rid of the water. That's what Pulp and Paper has to do with black liquor, and that's what DuPont has to do with titanium dioxide slurry. And then the other thing is that you still got a double mechanical seal, so eventually the inner seal is going to fail. This seal really has nothing to fail. If you think about it, it's just an air bubble. And the air bubble just sits there. It blocks the fluid from getting to the part that could fail. So as long as the air bubble is in place, this seal will last for a long, long time. I invited the fellow from Precoat Metals in Blytheville to come. He wasn't able to come, but he's got 98% sulfuric in the Gould's 3196 MTX. We have rebuilt that pump in this shop. It's going on 4 years now, and he's using the same seal. We put the same seal back in it after we rebuilt the pump that we had sold him originally. So have you ever heard of taking a used mechanical seal out of a pump and rebuilding it and putting that used seal back in? That doesn't happen. Yeah, you just don't do that. But
If you've got a high pressure pump, you have to inject air at a higher pressure than a high pressure pump to discharge.
yeah, Bruce was asking about the injection pressure versus the discharge pressure of the pump, and the answer is that it's not a function of discharge pressure, it's a function of stuffing box pressure. And the formula for stuffing box pressure on a centrifugal pump with an enclosed impeller is suction plus discharge divided by 4 plus suction. So whatever that figure is, that's a close approximation of your stuffing box pressure, and that's what you need to overcome with the bubble to be able to seal and keep the stuff from going down the shaft and leaking out on the ground. So it's not as much as the discharge pressure hardly ever, which is good because that will make it difficult for this system to work.
Any more questions? Again, for regular, normal process, if you have a solution for a very nice and cheap mechanical seal, good. If you have something which is different, you have the solution. Okay. You have another tool in your box to handle such a thing. Very good tool.
Josh, I had asked, before, what about 62% solid
Yes.
water?
Yes, and near Santo, the chief engineer that Udi mentioned earlier came back and said that was not possible with Tamar. It was 58% solids, is that correct? Yeah.
It's sticky? Or not?
He's asking, is it sticky?
It's below 100 centipoise.
What is it?
What was it?
Viscosity is below 100.
Below 100, so it's thin. But
It's
it's
the
high
first,
solid.
is the highest solid.
Abrasive?
Not quite as
Abrasive
abrasive,
solid?
not quite as abrasive as TL2 was.
Yes, it's abrasive, but not as abrasive as titanium dioxide.
Which kind of seal do you work with now? Which kind? Mechanical seal, packing seal?
Mechanical.
Mechanical seal? It's warm?
It works when we leak some fluid into the slurry feeding the spray dryer.
How long life is?
They don't change them like that all. You spray dryer,
Spray dry? No, not too bad.
probably 2 or 3 years.
2 years.
Stay with what No, we don't want to, I don't think that to replace all the mechanical seal, whatever. No, this is not a solution for it.
But did you say leaking was the problem, which you can't have it leaking back into the problem?
Spray dryers are evaporators. So any fluid going in with the solids decreases your capacity. So we can look at hose pumps, we've had successful hose, to get it less than the pack.
Okay. Okay. I would like to do a small brief what we did right now. Okay, just run it and give you some kind of application. You touch it or not, so give you some kind of information if you set such before and after. If you such application, okay, so the other solution like a ball mill. You see what they did before. They put a bucket to take the leakage, and we of course solve it. Powder. You see screw feeder. Just this is a vertical screw feeder. Vertical screw feeder. This is a lemon acid, known for of Israel. Mechanical seal, Tamar seal. After month of use, again, you will see a lot of screw feeders here, but give you just kind of knowledge about what we can do with that. Any kind of a powder application, if it's any kind of angle of it, double shaft screw feeder, single shaft, 60 degrees, 70 degrees, everything. You go Hastel we talk about metal, Hastel oil. Well, you see the degree of the screw feeder. This is what you have there. So everything goes down and kill the seal. You have a solution for that. This is the OEM. You see all the screw feeders with Tamar seal on it. 10 pages of 10. This is the guy with the Meko seal that replaces it. You have a rotary valve here. Again, you see the solution here. You see the solution here. Many of them. Next. You see here. This is one. This is the other. See how many years, months it's still working. You see, this is not new. But there are applications that are running for many years. Here, this is a barrel steel with high movement. Okay, one of the biggest problems is when the shaft is vibrating. And the run out. This run out goes compress the packing, taken to the side, and then there is a leak. And we can hold all of this situation. If the bellow or other things, we are more flexible because we have this active. This is a sugat. You will see many applications in the sugat. The red, hey, you're running too fast, my friend.
Yeah.
It says talk fast.
Maybe I will talk here. Reactors. 100. This is millimeter. I don't know if you know what's millimeter. Millimeters. Yeah. This is the Tamar road. You will see seals all over Tamar, one after another. And but reactors for aerators, agitators, dryers. This is one of the reactors doing installation. Well, go back.
יש משהו.
Go back.
יש את הצבע חשוב.
Yeah, go back. There is a paint. There is a bigger paint plant in Israel. Always there is one big one. This is Israel, small. Everything is one and big. Big in Israel, yes. Well, but it's a paint, and they have.
The ribbon mixer.
This is a ribbon mixer. Yeah, the material is like cement. It's very aggressive. And this is the seal here. Is around 6-inch shaft, and it's paint industry. You see here the seal. We see two boosters from both sides, and they have several of these. This is a new one, but several of these, and you go there and you see on the floor, all the paint on the floor. They try to work with packing, they try to do other stuff, but actually there is no much options in the market. Mechanical seal with such kind of sticky material like paint, very hard. They cannot, of course, put water there because it's diluted the process. They cannot dilute the process. This is the process that they are going to sell, so they cannot dilute it, and they have problems. So this is a solution for that. Right now they changed all their seals to Tamar seals. Okay. So this is in brief. I want to just one of the things that I want to show you. This is one. Okay. Okay. This is one we already gone through, and you saw that. I just want to remind you. And okay. So this is about the technology itself. Okay. Second. Just want to. Okay. So, any question about the technology? Jack is here, he installed the seals, know how to take them apart, put them together, know the matter with the seals. We are, of course, here as well. If you have any question, this is the time, friends.
Jack, the application we were talking about at Tamar, is that, I haven't had the opportunity to look at that. Is that gonna be a low RPM?
Yeah, it was low RPM, it was on a crusher, and they were 6-inch diameter shafts. And he was looking at using an Impro air seal, and they quote on their own website 10 CFM per inch of shaft. And he had 3 of them, so he had a total of 3 times 2 would be 6 seals, 6-inch diameter. You do the math, it's like 300 CFM.
Right.
I mean, it's just like crazy. And you saw there what the, I guess the side-by-side comparison between the Tamar and the Benzo. So so it's a big deal, and he's short of air.
Right.
So this and so we were talking about that application, June, before the meeting, and Ronnie and Udi both agreed that we're talking about probably 25% the amount of the air that the Impro seal uses.
He said that they were gonna make some changes to those seals and get them down to 15 CFM per seal, but that's still 30 CFM a unit, and that's 90 CFM.
Yeah. That's a lot of air. Because basically that design, you're just blowing air on the shaft to keep the powder away. So it's almost like an open jet. So you're using a lot of air to do that.
Right. And these are using less than 2 CFM, right? Or less than 1.
Yes.
Chemical compatibility to sealant, is there a particular sealant we have to use, or?
It depends on what you're pumping. I'll let them tell the story better than me, but my remembrance is that you tested over 400 different types of sealant.
Yeah.
And they have maybe 4 or 5 that they use the most regularly.
Yeah, sure. The sealant is a different story because, again, we need to provide sealant that can hold the pressure in one hand, that can hold with the process. So we actually test almost all the kind of sealant right now that you can even think of. And in the end, we do 2 things. First of all, we choose the 4 ones that are suitable to most process, and of course we are providing the one that is suitable for you. And we not invented, but we composed a few ones and prepared this that is meet our standards. So this is special sealant that we use as well.
And they have, you have MSD as
Of
sheets
course,
for all
of
the
course,
seals.
of course. Everything that we are providing.
So there is, and I can email anybody that wants one, a Tamar data sheet, I guess, for, like, to fill out, as far as what the application is, the temperatures, the fluids, that kind of thing. And
Like any mechanical seal that you sell, any seal that you would buy, you put the process, you do the pressure, you put all the environment, you put whatever you need. They give you the same. This is the same.
the seal that we were looking at this morning for a customer up in Kentucky, Steve, you might want to speak to that. That was for a horizontal mixer, right?
Yeah, horizontal mixing of chinon. So if you seal about 6-inch shafts on both ends of a horizontal reactor.
And it was 650 degrees Fahrenheit.
And 600 to PSI continuous.
Yeah, 6 to 650 PSI, and it was 15 RPM on the shaft. That's pretty tough service. They haven't been able to find anything so far to see it. They used Teflon packing, and he said it lasted about 6 months, but at the end of that time frame, the Teflon packing starts getting into it breaks up and gets into the chinon. They can't have that.
They said they replaced it 1 to 2 months.
Is it 1 to 2? Okay.
Oh, they had 6 machines, 6 horizontal reactors, and they replaced the packing every 1 to 2 months.
Think about it, packing started from the 19th century.
Right.
And we are talking about what kind of
All stories.
what kind of packing you will put. It's amazing, huh? Still. So we need to move forward.
Sure. Well, as we leave out this door here behind Steve, we've got John, correct me if I'm wrong, a Griswold pump.
Yeah, we've got one out there.
Okay, and we've got Tamar seal here. We're going to show you how easy it is to put a seal in one of these pumps once the pump is disassembled. It takes like 2.5 minutes. It's just not much at all. So if y'all like, let's just walk over here.
Hey, Jack.
Okay. If you look at that, you see this is the faces where this is one. It's not new. Okay, this is new, but this is not new. But still, you see the faces where here the sealant is touching in that area. When it's vibration, still is touching the vertical faces here. See? Okay.
That's it. That's how quick the seal goes on. So you're ready to both pump back up. Yeah. What you would do is you would put everything back together, set your end clearance on your filler, and then lock it on. That's it. And then when we started up the pump at Huber, we had an issue with we didn't tighten those enough, and that was slipping on the shaft. So we had to stop the pump and re-tighten it. Now it's only about 3 minutes. It's still cranked up.
Seal, if you order, you can't charge the time to use it back.
Yes, sir. And your reservoir comes already packed.
Yeah. What you get is a fully cartridge plug and play. That's it. What we will show you right now is inside. Inside the field is the story about the technology. And put it inside. Close the screw here. You go to the shop.
You got to follow that procedure, get it out step by step, and work down 4 or 5 times. Start this thing up.